Right. We already dealt with some properties of logarithms, right? The ones we just used in the homework, those are properties of logarithms, right? But there's other properties of logarithms that we're going to use in the lesson today, which are part of solving equations and all that. And the very first one, maybe not quite so much a property of logarithms, but it's something that we can do with logarithms, which is called change of base formula, right? A change of base. And change of base used to be kind of important, right? Because on your calculator, on a TI-83 or anything went before that, you only had those two logarithms that are on the front of your calculator, right? So you could do log base 10 or you could do log base e, ln, but you couldn't do any other base. That's not quite true anymore because in these yellow calculators, at least when you're using them in class, you've got a log base function that'll let you do a log of any base. But still, it is important in calculus, we do have to change the base of functions. If we get a logarithm that's not ln, we got to change it to ln. So we need to know how we're going to do that. But the basics of a change of base formula is, if you have a log of one base, which we'll do an example in a minute, this says log base a of x equals, and now we change base. The new base is going to be b. It'll be log base b of x divided by log base b of a. So it's like taking out of this here, right, the x goes in the top, the a goes in the bottom, new base. And because we're using a for the base and b, I mean, we're just talking, this could be any bases at all, right? It doesn't have to be any particular base. You can convert. So this x is the one that goes on top. Oops. And the a is the one that goes on the bottom. Now, the next two examples, those are the specifics, right? If you got a log base 10, then that would look like log x over log a. You know, just take these two things that are in the log on the left. The log x goes on the top, the log a goes on the bottom. You know, that was the common change of base that you would want to do because you had that one on your calculator. So you're more likely to do that. But you could do the same thing with ln. Right? You could go right here. You could say log base a of x is ln of x divided by ln of a. Again, when you get to calculus, you don't deal with other logarithms. You deal with ln's. And if you get a logarithm that's not a base e, an ln, then you got to change it. And it's not hard. You just do it like that. You know, the simple thing about it is, you know, the ln of a, since a is just a number, it's just a constant. I mean, it's a number. The variable is still all up here. Now, in class, you've got access to these calculators. If you were issued a calculator, you probably got an 83. So you would need to use a change of base formula if you got to do a logarithm any other base. So let's do a practice. Evaluate log base 2 of 12 without using the log base function. Just use a change of base formula. First, using common logs, right? So how would I rewrite log base 2 of 12 using common base 10 logarithms? What would be in the top? Log of try again. You had a 50-50 shot. The 12 goes in the top, the 2 goes in the bottom. Right? And that's something you can just put in the calculator. Log of 12. Yeah, and make sure when you put logarithms in the calculator, it pops up a left parenthesis. You need to close it off, right? So I got to close it off and do divided by log of 2. 3.5849, I'll call it 3.585. right? How would that look if I use natural logs to convert the base? It'd be ln of 12 divided by ln of 2, right? So you put that in the calculator. Ln of 12 divided by ln of 2. And it should be exactly the same thing, right? Because it doesn't matter what base you change it to, you should get the same decimal value. So that would be that'd be 3.585. Right? There's more on the end of that, but just rounding it off. Right? That's how change of bases work. Yeah, this is just an example to show that if I was given a function, which was, let's say it's even log base 10 of x in calculus, I would use the change of base formula to write that as ln of x over ln of 10. And the ln of 10 is just a constant. You could put in the calculator, it's about 2.3. And then that is something that you can deal with. The things that we do in calculus, derivatives and integrals and things like that, we can deal with that. We wouldn't be able to do the same thing with the log x, but it's a very simple conversion to go there. Right, these are the properties. These are, I think change of base formula is a thing to do, it's a procedure, but these are what we call the properties of logarithms. And again, they kind of relate to the properties of exponentials or exponents, because that's what logarithms equal, right? And that's why we created logarithms in the first place, right? We know that if we have something like 10 to the 10 squared times 10 to the third, right, that I can simplify that by adding the exponents, right? That's 10 to the 2 plus 3. Okay, well, we have a product property says that if I'm taking the logarithm of a product, u times v means it's a product, then you can make that the sum of the individual logarithms. That's the log of u plus the log of v. Again, it's changing a multiplication into an addition. And again, on the left column, that's with a log base a. On the right column, it's with ln. You know, if it works for any base, obviously it works for e. So that's product property. Quotient property, right? If you're taking the logarithm of a quotient, u divided by v, right? That's the logarithm of u minus the logarithm of v. Right? So we're changing a division into a subtraction. Quotient property. And the last is called power property. Right? If what's inside the logarithm is being raised to a power, that means everything inside is being raised to that same power, then you can take that power in front of the logarithm as a coefficient. So notice in here was log base a of u to the n. Now it's n times log base a of u. No more exponents. The exponent goes in front. Right? Or even over here, ln of u to the n is n ln of u. So what we do with the rest of this lesson is just use those properties in two ways, right? If you go from one logarithm to many logarithms like that, that's called expanding. Right? If you go from many logarithms to one, that's called condensing. Expand, condense. We ready? Okay. Now, when you look at the directions in the homework problems, don't be confused by all the words that they've got in there. The ones that say expand, right? They clearly say expand, right? Expand, expand. But it says a little more. It says use the properties of logarithms to expand the expression as a sum, difference, and/or constant multiple of logarithms, right? It just means expand, right? Whatever we're going to do in these examples, that's all you're doing, right? The condense is a little simpler. I mean, it does clearly say condense and condense, right? Condense the expression to the logarithm of a single quantity. So we will do, I think I've got like one expand and a couple condenses in here, right? Expand this expression, right? Again, that means take it from one logarithm to many logarithms, or as many as you need, right? There shouldn't be any exponents left inside any logarithms if you can help it. So which properties does it look like we're going to have to use here? Do we see any products inside the logarithm? Anything being multiplied? How about 4 times x squared? That's a product, right? Do you see any quotients inside the logarithm? Right? Anything being divided? Sure, that's what that fraction bar means, right? So you've got both of those going on at the very least. You see that 2 there, but you can't do a power property because that 2 is not the exponent for everything inside the logarithm, right? So don't try to think you could like take that 2 out in front. It would only be if it was the square, everything inside was squared. So first, we're going to split this up using the product property, using the quotient property. Now, you could do it in a couple steps, right? I could go, I'm going to use the quotient property first. All right, log of 4x squared minus the log of the square root of y. And then use the product property for this. What will that look like? The log of 4x squared is the log of 4. It's a product property, so it should be plus the log of x squared minus the log of the square root of y. Right. When you see it expanded, it ought to be that everything that came from the numerator is positive. Everything that came from the denominator is negative. Now, are we done? I mean, notice we couldn't use the power property here because that 2 was not the exponent of everything. But what about here? For that one individual logarithm, that 2 is the exponent for the whole argument. So you can pull that one in front, right? That'll be log of 4 plus 2 log of x. And then when you see a square root, remember that square root is the same thing as raising something to the 1/2 power. So that would be rewritten like log of y to the 1/2. And then you can use the power property again because of the exponent of 1/2. So if you see a square root or a third root or anything like that, yeah, you're supposed to turn it into a rational exponent so that you can use the power property. Again, now if you look back on those directions, right, write it as the sum, difference, or constant multiple of, right, sum and difference, and then multiplying. These are constant multiples of individual logarithms. Like here? Could it be a minus and then a plus? Sure. Sure. I mean, that would just tell, again, what would that tell you? I mean, I could rewrite this myself, just to switch the positions of these two. It wouldn't change where they came from, right? So that's just using basically a commutative property. I mean, the order you add things does not matter. So yeah, you could have minuses or pluses in any position. The main thing is, if it's plus, it came from the numerator. If it's minus, it came from the denominator. Yeah, I should have been writing the base of 3. Sorry. 3 and 3 and 3 and 3 and 3. Okay. 3 and 3 and 3. Thank you. You're good? Okay, condense. Okay, so which properties does it look like we'll have to use on this one in order to put these more than one logarithm into one logarithm? Does it look like there's a place for product property? Meaning, are the logarithms being added? Are there any logarithms being added to each other? No. Okay, so not a product property. How about a quotient property? Do you see any logarithms being subtracted? You sure do. So there's definitely going to be a quotient property because of that. And then it looks like there's probably going to be some power properties because we do have some coefficients of the logarithms, like here and here. So in a way, it's kind of like the order of operations. So let's go inside the parentheses first, right? We would like to put these two logarithms into one using the quotient property, right? But if you go back to that quotient property, right, that quotient property, that's 1 times a logarithm, 1 times a logarithm. You can't put them together until we've got a 1 in front of the logarithms. And we don't have that inside the parentheses, right? We have this 2. So how could I get rid of that 2, which is in front of the logarithms, so that I can use the quotient property? Use the power property, right? Move it inside the logarithm so that it looks like this. 2 times the log of x plus 3 minus the log of x minus 2 squared, and parentheses. Okay, now you have 1 times the log minus 1 times the log. Now you can use the quotient property, right? So what will that look like? 2 times log of, what goes in the numerator? The x plus 3. And in the denominator, x minus 2 squared. And I can put that in big parentheses just to make it clear. That's all the argument of the function, right? Don't write it. I mean, a common mistake is when you're using that quotient property that you're going to write that like the log of x plus 3 divided by the log of x minus 2. Now remember, you're taking more than one logarithm and putting them into one, right? You would never have a log divided by a log when you're condensing. Right, that's not what works. Okay, I'm still not done. Yeah, you could use the power property one more time because of this 2, which is in front. Move that inside as the exponent. Log. Was that a base 10? It was. Okay, so that's x plus 3 over x minus 2 squared. And then that whole thing is squared. Now, at that point, you've done everything you can to condense that into one logarithm, right? If there's more simplification that's being done inside the logarithm, it doesn't matter so much to me. I mean, you might see that in the book, they might have written that like x plus 3 squared over x minus 2 to the 4th. Certainly that's correct, right? But I wouldn't worry about it as long as you've got everything inside the one logarithm. You know, that's what we were really trying to get at here. Okay, got one more example of the same kind of thing. because I didn't think that their examples showed enough of this. So I grabbed one of the even number problems to show a little bit more. Okay, we're going to condense 3 logarithms into 1. Which properties do we see going on here? Okay, you definitely see quotient because of the subtractions, right? So the minus and minus telling you there's quotient. Can we do everything yet, or do we need to do some power property to make these 1 times a logarithm? Definitely you need to take that 3 and move it inside. So that would be 2 times ln of x minus ln of x plus 1 minus ln of x minus 1. Oh, sorry, to the 3rd. Right, and now we can put them all into 1. I mean, could you do this as a, like first do a quotient property between those 2 and then do another quotient property? Yeah, you could probably do that. What I would do is, if you've got inside all of your logarithms, right, that you're going to try to put into 1, then just write your logarithm. And again, everything that's coming from a positive logarithm, put it in the numerator. Everything that's coming from a negative logarithm, put it in the denominator. Right, so this one would be x to the 3rd over x plus 1 times x minus 1. And that's still got a 2 in front of it. So one last step, move the 2, right? ln of okay, and that would be done. Now, what if, for example, when we looked at this at the beginning, I almost wish I would have written it more like that, but I just copied the problem out of the book. What if it had in parentheses here these 2, and that meant that was a plus right there? I mean, it's the same thing. It's the same thing, but you don't want to be, you're going to look at that and say, oh, well, that's a plus, right? But it's not a plus because of the minus, which is in front of parentheses. So if you're going to use what I just said about everything that's plus, put in the numerator, everything that's minus, put in the denominator, first make sure you've just got no minuses in front of parentheses or anything like that. Distribute the minus, and then you can do it like that. Okay, so that's it. So again, this was the change of base formulas, which again, if you have an 83 at home, you really want to know how to do that because that'll help you with all the other bases. And then we use the properties to expand and to condense.